sound check, sound check. Hi, good morning, everyone. I hope my voice is clearly audible. So, today we are having a doubt clearing session on deep NLP. So, if any one of you has any doubts related to deep NLP, you can ask them in the chat section and we'll have a discussion of the doubts. All right, guys. So, we have a doubt here. The difference between NLP, deep NLP, and machine learning and deep learning. All right. So, see, what happens is natural language processing is purely a pre-processing technique. All right. So once your data is pre-processed and you have extracted the features, it gets converted into a form of a data frame or a NumPy array. All right. And if you're working with, let's say, TensorFlow and Keras, it gets converted into tensors. So finally, you'll be passing this particular data, which has features, into any of your models, like machine learning model or deep learning model, all right, or neural network architectures. So this is the basic difference. So NLP is purely a pre-processing technique wherein you'll simply deal with the text form of data and extract the features from that data. Once the data is extracted, or once the features are extracted, you'll be passing those features into any machine learning model or any deep learning model. All right. So, for example, let me just show you one of the projects that will help you to understand what exactly is the basic difference. All right. And coming to deep NLP, so deep NLP uses transformer based models. So, in transformer based models, every step, or it's better to say every neuron in the network is a neural network in itself. All right. So there is a lot of complex mathematics involved when it comes to deep NLP. All right. So you'll be using uh, pre-trained architectures like BERT in deep NLP. All right, here you go. So I hope everyone is able to see my screen. You can simply raise your hands to confirm the same. All right, all right. So basically, see, this is a NLP based project where we'll be using NLP purely for pre-processing, and then we'll be passing the data into a machine learning model. All right. So let's say this is the data set, which is fake news detection. All right. So will be the problem statement here is will be detecting fake news. Like given a data set, will be detecting which of the news is fake and which of the news is not fake. All right. So this is the problem statement, and your data contains first is the title of the news article, next is the author, third is the body of the article, and finally is the label. So label basically tells you whether it's fake or not. All right, so we'll use these import these standard libraries like pandas, read the data frame. Since it's stored in a CSV format, hence we'll use read underscore CSV, and then we'll check the first 5 entries of the data set. So this is what my data set looks like. All right, now what I'll be doing is I'm dropping the ID column because it is very ideal, or it is exactly matching to the index column. So since I already have index, hence I'll be dropping the ID column. All right. And then if I check the shape, I have 20,800 entries and 4 columns. All right. Now moving on, I'll just check the label of the data, and once I check the value count, I can see that both of these are almost balanced. All right. Next is we'll start with the cleaning of the data, which is we'll first check for the duplicate values. So we can find that 109 entries are duplicated, and we'll drop these entries. All right. So we'll all drop all the duplicate columns. And now if we check, the duplicate columns are 0. All right. Next is we'll check for the missing values. So as we can see, there are some missing values in title, author, and text column. So we'll be dealing with those. Right. So here I'll check the percentage of what percentage of values are missing. So as I can see, almost uh, there are less missing values in text column, but there are high missing values in author and text column. All right, so we'll be filling out the null values with a simple white space. All right, so all these values will be filled out in title and text column with a simple white space, but in author column will initiate a new category called missing. All right, and we'll be missing those. All right, so since we have filled out all the missing values, and if I check the missing values, it does not show any missing values in the data. All right, next we'll start with the pre-processing of the data. All right, so I'm just creating a function here which will be used for pre-processing for each of my data point. All right, so I'll be using the regex module, which is regular expressions. All right, and I'm defining a function deconcatenated, and I'll simply pass the phrase, or phrase is basically I'll simply pass a sentence. All right, so this sentence can be anything. So I'll be passing the title of the news, and then I'll be passing the text of the news. All right, so I'll be using these two. So we are performing a few um, replacements here. So basically, all the inverted commas will be replaced with the actual inverted comma that is defined in Python. All right. Similar goes with double inverted commas. All right. Next is the words like which are present in their short form, like won't will be converted into will not, can't will be converted into cannot. All right. Not will be converted into not, not. RE apostrophe RE will be converted into the actual word ARE. All right. Apostrophe S will be converted into S. Apostrophe D will be converted into wood. Apostrophe double L will be converted into will. Apostrophe T will be converted into not, although this has been repeated. So you can place it only once. Next, apostrophe VE will be converted into have, and apostrophe M will be converted into AMM. All right. So now, and finally, I'll return the phrase. So this is the function that I've defined, and I'll be using this function. So I'll be using the NLTK module, and I'll import the necessary uh, functions or classes from this module, and I'll download the stop words. All right. So if stop words are already available, you have already downloaded. So this step is not required. Otherwise, we'll have to download the stop words because we'll be removing the stop words at some point in time in pre-processing. All right. Now, well, you also have to download the PUNKT, which is the punctuation module, which will identify spaces or different kind of punctuations in your data. All right. Now, I'm defining the list of stop words. Those are defined in English, and assigning it to a variable called stop underscore words. All right. And I'm initiating an instance for WordNet lematizer. And once I have initiated the instance, now I'll start the pre-processing of my title column. All right. So I'm defining a empty list here, which is pre-processed titles, and it's an empty list. All right. Next is I'll initiate a for loop, and I'll simply iterate over each of the values in my train data titles column. All right. So I'll be taking title columns entry one by one, and I'll be pre-processing the data. So first I'll pass the function that I've defined. All right. And I'll pass the title columns first value, and then I'll pass the second value, and so on. All right. So each of the values I'm taking from the title column, I'll pass them one by one, and I'll perform all these operations. So first is I'll apply the function that I've called, so that all these, let's say, all these modifications go or take place inside this. All right. Next is I'll be substituting any hyperlinks that is present with a blank space. All right. So basically, we are removing the hyperlinks here, and this is the syntax that you can use. So this syntax basically says that anything followed by HTTPS is a hyperlink, right? Because every hyperlink or URL starts from HTTPS itself. All right. So I'm instructing that anything starts that is that starts with HTTPS is a hyperlink, and you'll have to remove it using a blank space. All right. Next is we'll be substituting all the special characters. That is, we are basically substituting anything that is present in the data apart from capital A to Z and small a to Z. If anything else is present in the data, like numbers or any kind of punctuation or any special character, we'll be removing it. All right. Next is we are removing the stop words. So how we are removing the stop word? Since this sent up till this step returns me a string or returns me a sentence. So what I'll do is I'll split the sentence, all right, using a white space, and so that each of my individual words are tokenized. Now I'll check if that particular word is present in the list of stop words that we have defined. If it is present, then remove it. If it's not present, then we'll take it. All right. So here all the stop words are removed, and next we'll perform the lemmatization technique, which is I'll simply apply lemmatizer, which will reduce all the stop words into their root form. All right. And since we already joined the sentences, basically we split these sentences so that each of my word gets tokenized, and then I'll check if it is present in my stop words or not. If it's not present, I'll take that word. But if it is present, I'll remove it. All right. And once I have removed all the stop words, I'll simply join all the words using a white space so that it gets converted into a sentence again. All right. I'll do the same thing while applying lemmatization. I'll split the word. I'll apply the lemmatizer to each individual words, and then I'll combine all the words using a white space between them. So again, it gets converted into a sentence. All right. Now, what I'll do is I'll append the final pre-processed word by converting into lower space, because since Python is a case sensitive language, hence I'll have to convert everything into lowercase so that let's say capital Apple and small apple, like apple in capital letters or apple in sentence case, is not different from apple written in lower cases. All right, so I'll convert every word into lowercase, and then I'll strip extra spaces if at all present in any word, or before any word or after any word. All right, so if any extra spaces are present, I'll strip those spaces. All right, now this will be done. All right, so basically from TQDM, import TQDM, we are just importing TQDM just so that we can see the status bar of the progress. All right, so if you apply this in real or in Jupyter Notebook, this will show you the status bar of the progress. All right, so I'll do the same operation for text data as well. All right, and yes, I forgot to mention one thing. I'm replacing my title column in the original data frame with the pre-processed titles that we have done. All right, so and I'll apply the same operation for text column of the trained data, and then I'll apply both of these operations in the test data as well, because I'm sure you guys are well aware of as of now that all the steps has to be exactly same for train and test data so that your results are not deviated. All right, so I'm applying the same operation on text data as well of my training data set, right? And I'm replacing the text data in the original data frame with the pre-processed text. Now, what I'll do is I'll import the train test split. All right, and I'll apply train test split in the data. All right, so first what I'll do is so what I'm doing here is I'm splitting my data set into three different data sets. First is training data set that will be used for training the model. Next is test data set, which will be used for testing the model. And finally, I'm dividing between a cross validation data set, which will be used to validate the data. All right, so I'll be applying cross validation techniques, I'll be using this CV data. So how I am doing this is basically I'm using train test split between my independent features and dependent feature. So output is my dependent feature. I have assigned output is equals to label column. All right. And the test size that I'm taking is 30%. So I'm dividing my data into 70s to 30. All right. And next, what I'm doing is I'm taking my training data and dividing into training and validation set. So basically, using this, I'll be dividing my complete data into train, test, and validation sets. All right. So out of lemmatization and stemming, you can use any one of these. It depends on the understanding that you have. In most of the cases, lemmatizer is more meaningful because it returns you the meaningful words, those already exist in an English dictionary. Stemming cannot ensure this. Stemming will provide you with the words those does not exist in English dictionary, and hence they are not meaningful words. All right. So lemmatization can ensure this, and hence I'm using lemmatization here. Although it purely depends on you only. You can use stemming as well. All right, both of them they are almost same, but they are not exactly same. All right, so this is the list of the shape of my train, test, and validation sets. So I've done this. All right, now I'll encode the data, or basically I'll perform the vectorization technique where my text form of data will be converted into numerical representation of the data. All right, so I'm using TF-IDF vectorizer to, I'll be using different techniques. The first is the TF-IDF vectorizer. All right, so the first TF-IDF vectorizer basically will convert the text form of data into the vectors representation of the same. All right, and I'm sure you guys are well aware of that TF-IDF is a frequency-based vectorization technique, which simply means that based on the number of times a word is occurring in the sentence, it assigns the importance to that particular word. All right, so higher the number of times any word is occurring, lower is the importance of that particular word in your complete corpus. All right, so I'll be initiating I'll be initiating the instance for TF-IDF vectorizer. All right. Next, I'll apply TF-IDF vectorizer on my title column of my training data set. I'll apply the title column on validation data set, and then I'll apply on the title column of my test data set. All right. So I've transformed my title column of all these three data sets using TF-IDF. All right. And next, like it's purely up to you. I'm just saving these transform words so that I can load them directly. All right. So if let's say these are the first 10 features of the data that is available. All right. So these are basically the first 10 words of the vectorized form. All right. Next, moving on, I'm just taking the number of unique values in the author column because I'll be performing certain operations. All right. So here, what I'm doing is I'm initiating an empty dictionary and I'm simply taking the author column from the test data set. All right. And yes, I'm taking the author column or train underscore author data set and I'm extracting the label column as my training output. All right. Now, what I'll do is I'll group the complete data set using author column. All right. I basically for every author, all the number of articles those are present, I'll list them together. All right. So this is what group by does. I'm grouping this train underscore author data frame using the author column itself. All right. So it will be grouped by the authors. Now I'll iterating over each of the authors here. So for I in train underscore author underscore one dot groups. So groups will basically represent all the list of authors, right? So I'm iterating over each of the author and then I'm getting the group of that particular author. All right. Next is I'll take the shape and the first entry of the shape. I'll assign it to total. So this will basically represent the total number of articles any particular author has. All right. Now, next is I'm extracting the fake column or the fake entry since my data is already labeled. So I'm extracting all the fake news given by that particular author. All right. And I'm extracting the first entry. So first entry gives me the number of rows, right? So the number of articles. So the number of articles any particular author has, those are labeled as fake. I'm extracting those fake columns or those fake news of that particular author. Next is I'm calculating the probability or basically the percentage of values or the percentage of articles any particular author has, those are labeled as fake. All right. And then I'm getting the non-fake probabilities. All right, and then I'm updating my dictionary with I. So I is the name of the author, right? And second is the a list of values where the first entry gives you the probability of the news not being fake, and second gives you the probability of fake news. All right, so this gives you basically the dictionary will return you how your dictionary will look like is name of name of the author is the key, and the respective values will be the probability of not fake and followed by the probability of fake. So you'll get this kind of entry for the complete dictionary for all the authors. All right. Now, what I'm doing is I'm iterating over train underscore author underscore response underscore code. So it's an empty list that I'm defining here. Right. We'll make use of this list if at all a new author is encountered who is not present in this fake news. So let's say there can be chances when you'll be testing your model, there can be chances that an author is encountered which is not present in your training data set. So how will you handle that particular author? So basically, how we'll handle that particular author is we'll assign the values of probability not fake and probability of fake with equal probabilities, which is zero point 0.5 and zero point 0.5. All right. And then we'll uh, and this is how we'll treat any new author. All right, so there will be 50-50 chances that that particular author has fake news and non-fake news with equal probabilities and equal chances. All right, I'm doing the same for the validation set as well and for the test set as well. All right, and finally I'm saving this dictionary which contains the list of authors and the probabilities of their articles being fake or not fake. All right. Next, I'm doing the same for the text column. I'll apply TF-IDF vectorizer. All right. I'll apply the TF-IDF vectorization technique on text column of my training data set, text column of my validation data set, and text column of my test data set. All right. I'm saving the features, just checking the first 10 features. All right. Now, second method that I'm using is word to wake technique. All right. So word to wake is one of the most popular techniques that is used because it is not frequency based vectorization technique, and hence it is able to identify the relationship between words. All right. So how any two words are related, this particular model can easily tell you about it. Right. So I'm using a pre-trained word to wake model called Globe. All right. So Globe basically stands for global representation of the vectors. All right, and we are using a pre-trained Glove model. So there are different kind of Glove models; those are present, and there are different uh, size of words that are present in the Glove models. All right, so the particular file that I'm using, this is the name of the file that I'm using. So glove.42b.300d.txt. I'll tell you what these words exactly mean and how different Glove models are present. So this basically means, let me, yes. So since Glove models are basically present in numerous number of, like it contains numerous number of words. So the first edition of Glove that was released contained 300 million words. All right. The second model that was released, and of course, these words were extracted from Wikipedia. All right. Next, the next model that was released contained 1.2 billion words. All right, and these words were also part of Wikipedia only. The next version that was released contained somewhere around 10.3 billion words. All right, and the source of the data was Twitter this time. And these are unique words. All right, make sure all these words are unique words. No word is repeating. All right, the next version that was released contained somewhere around 24 billion words. All right, and the source of the data was again Twitter this time. The next version that was released contained 42 billion words, and the source of the data this time was Wikipedia again. All right, so this is the model that I'm using. So 42B represents 42 billion words. All right, and all these words, like initially, let me just tell you that initially this was each of the individual words in these 300 million words, every word was represented in 300 dimensions. Sorry, 100 dimensions for the first version. All right, for the second version as well, it was 100 dimensions only. For later versions, the number of dimensions increased to 200 dimensions. All right, for this as well, it contained the words in 200 dimensions. And finally, when 42 billion words corpus was released, that was trained on Wikipedia, this was represented in 300 dimensions. So each of the word is represented in 300 dimensions. This is what exactly this 300D tells you. All right, so these models are already available. All right, you can simply download or simply run this function and import or call this particular model, and the words will already get downloaded. All right. So you do not have to worry about it. All right, you can even use the compressed version of it. That is purely up to you. All right, now moving on, since I have used this pre-trained model to train my words, hence I'll be saving these models. All right, and model dot keys will give you the model that you have trained on your data set. All right, so basically when I called this globe model, the total number of unique words that were loaded was 1917494. So these are the number of words those are present in my corpus. Right, all other irrelevant words are not being taken. All right, so that your globe model can make more precise predictions. All right, now what we'll do is we'll apply word to vec on title column and then on the text column of all the three data sets. All right, so I'm doing the same here. I'm applying globe model one by one. All right, and I'm converting every word into vectors into 300 dimensions. All right, so that the features that I get, so np dot zeros basically will create a matrix with of length 0 but in 300 dimensions. Right, so we'll be uh, will be iterating over each of the word in the sentence, and each of the sentence basically contains each of the values in my title column. All right, and then I'll simply add the vector, or I'll simply assign the vector from the model of the word by passing the word into my model, and model is we have defined here. This is the model. All right, so I'm basically passing word to vec. I'm applying word to vec to each of my sentences. All right, and then I'll simply keep a count of the words. All right, so if the count of the words is not 0, we'll basically divide the vector and by the number of words, and then finally we'll append this vector into the empty list that we have defined here. All right. So average word to vectors train, sorry, title train. All right. So this is will be storing all the words or the vectorized form of word to vec in these lists. All right. I'll do the same for cross validations data set, title column, and the test validation, sorry, the test data set in my title column. All right. So once I have done this, I'll be performing the same operation on the text columns of all three data sets. All right. So this is the pre-processing that we are doing, and this is where NLP is involved. All right. So I'm doing the same for the text column of my training data set, text column of my validation data set, and text column of my test data set. So once everything is done, I'm combining all the encoded features. I'll simply use the horizontal stack method because every word to vec and every TF-IDF vectorizer, these will give me the output in the form of sparse matrix. Just to save space, all right, so I'll first combine all the TF-IDF vectorized encoded features. I'll use the horizontal stack, which means uh, these will be combined one by one. All right, and then we'll be combining the word to vec encoded features. All right, so we'll use the concatenate method of NumPy to combine all my features. Now, since all my features have been encoded and everything has been done, my basically my words has been converted into the form of a data frame where each of my column represents each of the single individual words, and the respective row values represent the vectorized form of these words. All right, so this is where this is like until here NLP is involved. NLP is purely a pre-processing technique, and until this 7.2 NLP is involved. All right. Furthermore, NLP is not involved. We are simply passing all the let's say first will of course scale the data. All right, we'll scale all the individual data sets. All right, and then we'll pass this into the machine learning algorithms like multinomial NB or logistic regression. All right, so up till here, before modeling, up till pre-processing, NLP is involved. After this, the technique is very similar. All right, the technique is very similar. We are passing our data set into let's say multinomial NB first. All right, so this is train underscore data underscore final underscore TF-IDF. So this is TF-IDF transformed data on my training data set. All right, and this is my output. So this is basically x comma y that you pass, or x train underscore sorry, x train comma y train that you pass in any machine learning algorithm. Right. So up till here, your machine like up till like before modeling, NLP was involved. From now onwards, your machine learning algorithm will work how they usually work. All right. So in place of machine learning algorithm, you can use deep learning algorithms as well. Simply flatten the data and pass it into as an input into your machine learning algorithm. All right. So this is how like NLP projects are done, and NLP is purely a pre-processing technique. In the similar way, when you are working with let's say CNNs or image form of data, so the convolutional neural network is basically what it is doing is it helps you to extract the features from each of the individual words, sorry, each of the individual images. All right, so CNN is also a pre-processing technique, and finally the extracted features are passed into a machine neural network architecture. All right, so CNN and NLP, both of these are the pre-processing techniques where you'll pre-process the relevant form of data. So if you want to pre-process the text form of data, you'll be using NLP technique, and if you want to pre-process the image form of or video form of data, you'll use the CNN architectures. All right. So this is how they are different. Although in CNN architecture, if you look at the CNN architecture, the uh, neural network at the end is already part of CNN architecture. But in the initial steps of the architecture, you will be applying the let's say kernel matrix to extract the features. All right, or the convolutional, you'll be performing convolutional operations to extract the features. Right. So yes, guys, this is how NLP is different from machine learning or deep learning. I hope this was clear. All right, so basically here we are using different combinations. I'll use naive Bayes with TF-IDF, then I'll use naive Bayes with word-to-vec, then I'll use logistic regression with TF-IDF, and then I'll use logistic regression with word-to-vec. All right, and then I'll compare all these four models, which of them is performing better, and finally I'll take that particular model as my final model. All right, so I'll just scroll down and scroll through so here I'm using multinomial NV, all right, along with the TF-IDF. All right, next. So as you can see, since we have transformed the values or performed the pre-processing technique or the pre-processing operations very precisely, hence we are getting very good performance. The train AUC score is almost 99.9, right? And we are getting almost same score for validation set as well. F1 score as well, 99.9, and the F1 score for validation as well is getting very close to 99. So it's almost 98, right? 97.9 is almost equal to 98 if you round off the values. All right, so we are checking for the different values of alpha, and we are getting a good performance, right? In the similar manner, so basically here we are finalizing the value of alpha here, all right, which gives us the highest AUC and F1 for both validation and training data sets. So the value of alpha of 1 is giving us the best accuracy or best performance. Hence, we are selecting the value of alpha as 1. And then finally training our model using the same data sets, making predictions, and finally checking the test AUC and test F1 score, which we are getting very good. All right. So area under the curve of 99.9 is a very good performance. It's almost equal to 1. All right. And make sure this is not overfitting, because we are getting 99.9 of accuracy for all the data sets like training, test, and validation. So this model is not overfitting. You can ideally get good values for AUC, F1 score, accuracy, etc. All right. And now we'll check the classification report. So you can see that the classification report results in a very good outputs, right? And finally, we are using logistic regression with word-to-vec. All right, and we'll check the performance. So this time we'll be iterating over the value of C. So to check, we are getting again very good accuracy for AUC. For training data set, we are getting 98.8, which is almost equals to 99, right? And for cross validation as well, we are getting 98. So these two are very close to each other, right? And if we change the values of C, the value of AUC for training and validation also increases. All right, so we'll finally accept the value of C as 0.01, and the test AUC that we are getting is 99.6, and F1 score is 97. Very good accuracy and very good F1 score, acceptable, right? And finally, as a conclusion, we are selecting the naive Bayes algorithm as our final model because it's giving us better accuracy, right? So this is how the let's say this is how you can work with NLP, and you can try combination of different vectorization techniques along let's say clubbed with different machine learning or deep learning algorithms. So, guys, of course, I can show you the deployment of the model, but it's a very time-taking process. I'll have to, make my local system as the server, and then I'll deploy the model. So it's a time-taking process. We'll keep it for some other day. All right, you can basically deploy your model. There's absolutely not a problem. And how you can deploy is you'll have to create the Python file first, which is .py file. Usually in Jupyter Notebook, the kind of file that you're working on is .ipynb file. All right, so there's a difference between Jupyter Notebook and the Python script. You'll have to create the Python script. All right, and that script will basically contain all the process that is involved in your project, and then you'll have to deploy that Python script. Right? Although these days, if you use cloud-based services like AWS or Google Cloud, etc., or Microsoft Azure, for example, so you can deploy your Jupyter Notebook itself. All right. So, but in local system, you'll have to deploy your Python script, not the Jupyter Notebook file. All right. So of course, we'll keep it for some other day. The deployment of the model. We'll deploy the same model that we are discussing today. All right. And I'll show you how you can deploy this model right from scratch and what all are the things you'll have to keep in mind before you deploy the model. All right. And also you'll have to create the GUI, which is graphical user interface, which is basically the kind of interface that will contain all the inputs, because the input needs to be provided for your model to make predictions, right? So, for example, if we deploy this particular model, we have text column, we have title column, we have authors column. All right. So all these inputs needs to be provided by the user, and to create that GUI, we'll be using a library called tkinter, and using tkinter, you can directly create the GUI, and that GUI will be opening in the, let's say if you're running it on your kernel, for example, if you're running it on command prompt, so GUI will be open in command prompt itself. And if you're deploying it in such a manner that you're creating a basic web page, then it will be opened in your web browser. All right. So there are different ways those are used. And we'll see one of the ways where we'll be using tkinter to simply create a GUI on our kernel itself, and it will simply pop up a new window with the GUI that contains the inputs, and you'll have to provide the input to get the output. Guys, for let's say for cloud services, I'm sure you guys are well aware that cloud services are not free of cost, and it needs an instance to run. Like how a website is running, in the similar way, if you're deploying a model, a machine learning model, an instance is running all the time in the backend. All right, and that instance, until it's running, it works very similar to how instance is run for any particular website. Until that instance is running, your website is working. The moment that instance stops running at the backend in your cloud server, the same moment your website will stop working. All right. So this similar thing happens with machine learning models as well. If you deploy a machine learning model on cloud, it needs an instance to run. Until that instance is running, your machine learning model is live. The moment that instance is closed, your machine learning model will stop working. All right. So there are basically various things involved when working with AWS. All right. So basically, you'll have to build a system on AWS cloud. All right. So there are different things, like for example, AWS Redshift will be used. AWS S3 bucket will be used. S3 bucket acts as the hard drive, uh, act as how hard drive acts in your local system. All right. In the similar way, you'll have to take the local memory as well. All right. So there are different services of AWS. Those are used at the same time to get your model deployed and working. All right. So you'll have to like how your local system has RAM and ROM, for example, the hard disk, right? And let's say instances. So everything will be uh, taken on AWS, and there are different services involved. So as and when the services are used, they are clubbed together, and then your machine learning model is deployed. All right. So we'll try to keep that as well. All right. So like basically AWS, although it provides free credit till some extent, so just for the demonstration purposes, I'll try to take that into consideration, and we'll show you how to deploy a model on AWS. All right. And the models are deployed in a similar manner in all the cloud platforms, only the services are different. Let's say if you're using Google services, so the Google services are different from AWS, and it's different from Microsoft Azure. So, or it's this is also different from IBM Watson Studio that you're using, right? So, yeah, basically, all the cloud services are unique in their form, but the most uh, popular cloud services those are used is first is the Amazon Web Services, which is AWS, and second is the IBM Watson Studio. All right, so both of these are almost equally used in the market. All right, guys. So I believe that was all for the session for today, and we'll see what can be like how we can show deployment in the upcoming doubt clearing session. All right. So yes, guys, thank you for joining the um, session today. All right. You have a good day and great weekend ahead.